Hi, this is Eric Roth from EDD Academy, and we're going to be doing AP Calculus AB Unit 8, Lesson 2, Area Between Curves. So, as you recall from last unit, the integral can represent the area under a curve, and we're going to basically use this concept to derive the area between two curves. So, let's say we're trying to find the area between these two curves. Well, we're going to do an approach that is very similar to what we used when we were trying to find the area under a curve, but this time we're going to maybe specify it a little bit to find the area between two curves. So as you can imagine, I'm just going to draw some intervals here. Now these are some pretty wide intervals, but that doesn't matter for our explanation. So using these intervals, we're going to actually try to figure out how to find the area between curves. So let's just look at this, just look at the blue graph. So let's try to find the area under this blue graph. So I'll shade that in real quick. So that's kind of a rough shade of what the area under that blue graph is going to look like. And now let's actually look. I'm just going to swipe the pen the other way to show what the area under the red graph is going to look like. So that's going to look like so what's one thing that we notice here? Well, if we want to find the area between the blue graph and the red graph, we actually want to look at this area that they don't intersect in. So since the blue graph is bigger than the red graph, there is a section that the area under the blue graph does not intersect the area under the red graph. However, for the entire area under the red graph, it intersects part of the area under the blue graph. So what we're trying to find is this area right here. And intuitively, you can kind of figure out that if you take the area under the blue graph, so the integral of the blue graph, and then subtract the integral or the area of the red graph, you actually get the area in between. And this is kind of a neat property because now we have a way to find the area between two curves. So putting what we just did on the last slide into mathematical terms, we have a simple formula for the area between curves. And that is going to be the integral from a to b of f of x minus g of x dx, where f of x is bigger than or equal to g of x. Although you should notice that if f of x is equal to g of x, then the area between them is 0. So we're going to be doing a quick example of the formula that we saw on the last slide, which is actually the exact graphs we used in our example. So blue represents the square root of x, and red represents x squared. So we're going to try and find the area between root x and x squared. So the first thing is we want to kind of define what f of x and g of x is. And we know that f of x has to be bigger than g of x. And for this problem, we're just going to be finding the area between this point and 0. So actually 0 and 1. So on this entire interval, square root of x is actually bigger than x squared. So we're going to say f of x is equal to root x. And then for g of x is just the other function. So g of x is equal to x squared. Now we have everything we need to set it up. So it's the integral from 0 to 1 of root x minus x squared dx. And we should know how to integrate both of these functions. And you know that from the addition property of integrals, you can actually split this up into the integral of square root of x minus the integral of x squared. But we can do this all kind of in one step. So this is equal to 2/3 x to the 3/2 minus 1/3 x to the third from 0 to 1. And you should just know these from integration techniques. But yeah, so now we just need to evaluate this. So first we'll plug in 1. So we get 2/3 times 1 to the 3/2 minus 1/3 times 1 to the third. And then we want to subtract the whole of the other one. So subtract 2/3 0 to the 3/2 minus 1/3 0 to the third. However, we notice that this right half is equal to 0, so we can just kind of cross all of that off. And then from this, we know that 1 to any power of n is just equal to 1. So we can simplify this as 2/3 minus 1/3. And this is just simple calculation. So our final answer for the area between these two curves is 1/3. So if you want to do more problems like this, the general strategy is to find a bigger function and a smaller function and take the integral of the bounds, so whatever x value to whatever x value of the bigger function minus the smaller function.